Hey guys, welcome back to my channel. And today we're going to get some math problems done. So let's get into it. We're going to be working on 12.7, which is called radical ideas. And what we're really doing is simplifying radical expressions. And when I say the word simplifying radical expressions, it just means I'm rewriting something that looks like this to make it more look like this. Okay. So I don't want, a $20 bill. I'd rather have a 10, a 5, and 5 ones or something. So this is the preferred look when you're leaving an answer, because you can't simplify it anymore. There's nothing else left for you to do. Okay, so we're going to take this guy who there's things that we can do with him, and then we're going to exchange it, or kind of like break the that $20 bill into parts that we can use better, right? So remember that Tia's method, she uses radicals over and over again, but Tahani likes exponents over and over again. Absolutely. Absolutely. And no quiz today. Okay. So what we're going to do right now, I know, right? So what we're going to do right now is we're going to break up this square root of 20 x to the 7th. And I already asked you guys to start on this. So we're going to just already jump on in. So it says square root of 20 x to the 7th. So Tia is always going to break it down into parts that you could easily take the square root of, if that makes sense. So if I think about 20 and I think about x to the 7th, does anybody see any perfect like sets of anything? Does anybody see any perfect sets of anything? Okay. Yeah, there's a bunch of stuff in here. So because we're looking for sets of 2, I'm going to come over here and break down the square root of 20. And then I'm going to break down the square root of x to the 7th. So the very first thing is I'm going to break down these two guys as if they're separate and then put them back together. Very good. So what could I break 20 into? What could I break 20 into? Yeah, very good. Someone says 5 and 4. If you didn't choose 5 and 4 and you said 2 and 10, congratulations. That's all good. That's all great. Okay. Someone said 5 and 4. I looked up. That's the first one that I chose. So again, it would work if you did 10 and 2, but I'm just choosing 5 and 4. So I'm going to break 4 down into 2 times 2, and then I'm going to bring 5 down so they're all on the same level. Okay. So again, I'm looking for pairs of shoes, right? I'm looking for pairs of shoes. Does anybody see any pairs of shoes here? Yeah, someone says, oh, I see 2 2s, Miss Johnson. So, okay. So the 2 goes on the outside, right? The 2 goes on the outside. And then what happens with this 5? What happens with this 5? What happens with this 5? Sorry, it's kind of slow right now. So I'm going to have it catch up to me. Yeah, leave it alone. Leave it alone where? Where does he go? Yes, he stays on the inside. Very good. So you should now understand why the 2 is on the outside and why the 5 has to stay on the inside. So can you say to yourself, or can you tell the class, why does the 2 have to, why does the 2 get to go outside? And why does the 5 have to stay inside? Go ahead and tell some of your classmates that. I want to hear from you guys, just so that I can grab some of this attendance stuff. Good job. I'm just grabbing your participation in the chat. Really good job. So how would you explain that to someone? Why does 5 have to stay inside? Why does 2 have to go outside? Very good. Good job. Okay. I'm just writing a couple more down. Very good. Let me grab the last couple of ones that you guys all said. Very good. Someone said, because it's paired and 5 is not. Is everybody okay with that? Someone says because it's paired and they're referring to the 2 and the 5 doesn't. Someone else says the 2 has a pair and the 5 doesn't. Someone else says because we can't break 5 into 2s. Very good. We also have an explanation of, hold on a second, I lost it. Because one is playing outside and one's playing inside. Very good. 5 is the lonely man. Exactly. Very good. Yeah, so any pairs. Okay, so I just pretend like, just so that you guys can understand it. It's not a perfect explanation, but it's pretty good. So I'm going to pretend I go to the store and I'm going to go buy some shoes. I find these shoes and I'm like, okay, well, I can buy these shoes, right? And I found a really cute shoe, but I can't find the other shoe. Do you think, even though it's a really, really cute shoe, do you think I'm ever going to buy one shoe? Everyone says like, no, Miss Johnson. And that's correct. I'm not going to buy one shoe. It's going to stay in the store. Does that make sense? So do the same thing with your x to the 7th. I'm going to pause really quick. Do the same thing with the x to the 7th and see what you guys get. All right. Give me a second. Let me pause our video. Okay. So now you're going to go through and do x to the 7th, right? You're going to go through and find x to the 7th, right? So how many pairs of stuff can I actually pull out from x to the 7th? All right, come on back, guys. Come on back. How many pairs of stuff can I actually pull out for x to the 7th? Okay. Yeah, so what you're going to do is you're just going to write out x to the 7th. And so can you just pretend it's x, 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 x. Wait, 1, 2, 3, 4, 5, 6, 7. And what am I looking for? Anybody know? What am I looking for? Yes, very good. So someone says, hey, Ms. Johnson, I have this many pairs. Exactly. So how many pairs can I get out of x to the 7th? So if you don't know, you just count. So I got 1 pair, so I'll write x, another pair, so times x, a third pair times x. And what happens to this guy right here? What happens to my last guy? Yeah, he has to stay in the shoe store, right? He stays. So how do I rewrite? Uh-oh, it's going to catch up. How do I rewrite x times x times x square root of x? How do I rewrite that? What is x times x times x? That's what I'm really asking. Yeah, very good. X to the 3rd. So this is going to be x to the 3rd square root of x. Everybody okay with that? Yeah, x to the 3rd times, okay, very good. So then now, can you imagine that it says x to the 3rd times square root of x right here? Okay, so now I have to put this all together. Yeah, now we have to put this all together. So what is going to be my final answer right here? What is my final answer going to be right here? Yes, x times x times x equals x to the 3rd. Very creative writing there. What do you guys think? How do I multiply these two together? Who do you think goes together? Hint, hint. Who do you think goes together? No. Like with this, because now I did these separately. I did the number separate from the x's, right? So now I'm putting them all together. So who goes with 2? Yeah. Why does 2 go with x cubed? Why do you think 2 goes with x cubed? Because they're both where? Where are they both? Yeah, they're both outside. Very good. Okay. So you want me to put 2x cubed on the outside, Miss Johnson? Mm-hmm. What's the rest of my answer say? What's the rest of my answer say? What's the rest of my answer say? But, oh, just write 5x like this? Everyone say no. No, Miss Johnson, no. Good, no, inside the radical. Very good. So here's your final answer, 2x cubed times the square root of 5x. Now listen, some people want to still say, oh, Miss Johnson, you could still simplify this. And they'll multiply the inside stuff with the outside stuff. They don't get to play together. They don't, okay? So my final answer for Tia's method, and it doesn't matter, it's going to look the same, is 2x cubed square root of 5x. Okay, I'm going to do some side knowledge here. Who's being cubed here? Look at this. Who is being cubed here? Who is being cubed right here? Yes, just the x, not the 2. Not the 2. Okay, if I wanted to show you that it was that 2 and x were being cubed, what would I have to write in there? I'll say that again. So if I wanted to show you that 2 and x were being cubed, right, what would I have to write in here? No? No, yeah, you can put an exponent for 2, but another way to write this is look at that versus this, okay? So I want to show you, I'm going to use 2 different variables just so that you guys understand this is not the same problem. So what if I showed you this? This is anticlimactic, you guys. I don't know what to tell you. Oh, there it goes. All right. So what's the difference between, I know, loading. Here we go. What's the difference between this and this? What do you see is the difference? What's the biggest difference that you see? No, sorry. Ignore the square root of 5x. Just look at 2x cubed and 5y quantity to the fourth. So ignore the radical for now. I'm focusing on one thing. Yeah, it's parentheses. So mark my words. This is one of the biggest mistakes my students make is they see 2x cubed and they want to cube 2. No way. Okay. This cube will sit on whoever it sees. It can't see that 2. In fact, 2 has its own exponent. It's invisible, but it's there. So what is 2's exponent and it's invisible? What is 2's invisible exponent? So 1. Very good. So don't give this 3 to 2 when 2 already has his exponent. Does that make sense? Don't give into that, because I don't know how or why, but that's what people end up thinking. I've seen it for years. So if I want everything to be included in that fourth, do you see what I would use? I would use this parentheses, which means this applies to everybody until inside my parentheses. All right, very good. All right. All right, so Tahani's method, we're going to go with exponents. Tahani's method, we're going to go with exponents. So I am going to write it over here. So let's see. So here we go 20. Oops, this is still the glitter pen. Hold on. So we go 20 x to the 7th square root. How do I write square root in exponent land? How do I write the square root in exponent land? Yeah, to the 1/2. Woo woo. So we write it like this. We write 20x to the 7th to the 1/2. Very good. Okay, using our properties, what would happen next? Using our properties, what would happen next? Please hold. Please hold right now, real quick. Okay, so what would you do here? What's the property? That's good. Trying is important. What's the property that we are working on here? What's the property that we should use here? Anybody remember this property? Yeah, it's the power of the power rules, which basically says when you have a power on the outside, you give him to each of these. Does that make sense? Sorry. So I'm going to take this 1/2 to 20 and this 1/2 to the 7th for X. Does that make sense? So if we're comparing Tahani's and Tia's method, this part right here just happened right here when I separated them and said, you go under the square root and you go under the square root. Does that make sense? Very good. Awesome work. Very good. Okay. So then what happens? So then this 20 to the 1/2, even though it looks like this is where my brain is thinking right here. This is what my brain is thinking right here. Right? So then I would go something along this lines. For the 20, it would look like this. It would be 4 to the 1/2 times 5 to the 1/2. See? 4 to the 1/2 times 5 to the 1/2. Right? I'm going to keep on the 20 for just a second, and I'm going to ignore this x to the 7/2 or x to the 7 to the 1/2. And then you should know that the square root of 4, what is the square root of 4, by the way? What is the square root of 4? Very good. It's just 2. So I'm just going to write 2 right here times 5 to the 1/2. Now, people do this all the time. Hey, Miss Johnson, what do you think they ask right here? Hey, Miss Johnson, what do you think they ask? Hey, Miss Johnson, can we, give me 1 second. Yes. Can we multiply these two? Yeah, people ask this all the time. Can we multiply these two? Everyone say no. No. Now, the reason why we can't multiply them is because this exponent 1 and this exponent 1/2 are different. Now, the reason why you can multiply, I know you guys have never thought about this, but I'm going to make your brains kind of think, Miss Johnson, then why can I multiply this? Why can I multiply 2 times 5? Because this exponent and this exponent are the same. Now, I never had to tell you that because we never had, unlike, exponents, but now that we're introducing those, that's why I can't multiply these two together. That's why they sit like this. This is when you fight the urge. Don't multiply those together. Do you guys all see me fighting the urge? Fight it. Don't do it. Don't you do it. You understand what I'm saying? Don't you do it. Everybody good? Okay. So that's very similar to the urge that people want to go here. Miss Johnson, I can multiply these two together, right? And the answer is no. So because you can multiply them here because they have the same exponent, these two do not have the same exponent. See, this is what their exponents look like, right? Yeah, well, technically both have the same exponents, right? This is a 1 and this is a 1, right? Very good. Okay. Now, some of you are saying, so we just leave them like that, Miss Johnson? Yes, you leave it like that, just like you left it like this. Okay, now let's do the x's. Now this x says, where am I? Over here. So it's x to the 7th times 1/2. What's 7 times 1/2? What's 7 times 1/2? Yeah, 7 times 1/2 is 3.5. So I'm going to write it like this: 3 plus 1/2, right? You guys remember this? 3 plus 1/2. So I'm going to write this right below here, times x to the 3rd, and then x to the 1/2. I'm going to separate them out and you'll see why. So who should I put? Now this part right here is really this part right here. Do you guys all see the same thing? Do you see 2? 2. Even though you see 5 to the 1/2, your brain should be saying, that means square root of 5. And you're like, yeah, that's right. Right? And then do you all see the x cubed? Do you all see the x cubed? and this is x to the 1.5, and you're like, I don't see x. And then your brain says, yeah, that means the square root of x, right? So we want to make sure that even though we see this, we're still thinking this kind of thing. That's the best way for you to like be more comfortable with exponents is like see it and remember what it actually means, right? Okay, so just like I asked you here, who can go together here, and you pulled all the terms outside the radical in front. So who's going to go out in front? Yeah, it's going to be 2x cubed. And who are the people inside the radical? Yeah, the 5 and the x. And I'm just going to write it again as 5x under the radical because they wanted your answer in terms of radicals. So here's your final answer. So if I had to make you vote right now, who do you like better, Tia's or Tahani's? Whose method do you like better, Tia's or Tahani's? Yeah, most people like Tia's method. But here's what you don't realize. Tahani's method is just the same. It's just in the different language. Remember how we talked about radical languages versus exponent languages? So this is like in English and this is like in Spanish. They mean the same thing. You get the same results. One is just preferred. So in your household, there's a preferred language. And some of those languages are a little bit mixed, right? So just keep that in mind. So there's your answer. So with that being said, I'm going to have you do this with your preferred method. With that being said, I'm going to have you try this with your preferred method. Okay, so hopefully you all simplified first before you got into the cube root. And that's my general rule of thumb, right? My general rule of thumb for handling math problems is always going to be, can I simplify before I do this big thing? Okay, so I'm going to just do this Tia's method because you all said Tia's method, Miss Johnson. So I go cube root, and I'm actually going to show a little bit of Tahani's just so you see and get practice with that. Because if you practice the things that you're not so good at, your weakness becomes a strength, right? So the very first thing that I notice is I see that these X's on top and on bottom. So can you imagine, right? I have an X on the top and then I have these 7 X's on the bottom. 1, 2, 3, 4, 5, 6, 7. What would happen? What would happen if I had this X on top and all these X's on the bottom? How would you simplify that? What would you say? What would you do? Come on, y'all. What would you do? Yeah, you would cancel them out or you would divide, right? So then this guy here, right? This is what I always do. I always draw like a number 1. Do you guys all see my 1? So my students made fun of me and they're like, Ms. Jonathan, it looks like a half t-shirt. I'm like, fine, but it's 1. So X divided by X is 1, right? So then it's almost like I can cancel them out. I don't like the word cancel them out because it sounds like zeros, and it's not a 0 because 0 times anything is going to be 0. So it's a 1. It does look like a half t-shirt. I know. So then how many X's do I have and where are they? How many X's do I have and where are they? Very good. Very good. I have X to the 6th on the bottom. Is everybody comfortable with X to the 6th on the bottom? And now you like it better because X to the 6th, knowing that we're dealing with a cube root, all of you are like, okay, I like that better, right? Does everybody see that? So it is going to catch up to you, I promise. Okay. Okay. So let's try that with the Y's. Can you guys try that with the Y's now? Try that with your Y's and see what you get, what is left. So please try that. Okay, so if we take their Y's and do it the same exact thing here, and I'm just going to scoot it over just a little bit so you have more room to think about it. I have Y to the 5th on top, Y, because I said so, just kidding. Y. Yes, ma'am. What do I do now? How do I simplify this? What would happen? Yes, very good. I have 2 sets of 1, but I'm just going to make a fatter white t-shirt. Do you guys all see my bigger one right there? Just going to grab 2 of them at the same time because y times y divided by y times y would just be y. Very good. Someone said, hey, Ms. Johnson, would it just be y cubed on the top or on the bottom? Would y cubed be on the top or on the bottom? Very good. Y cubed on the top. And some of you are like, hey, Ms. Johnson, but that's that rule, right? You told us earlier, if we're dividing, we could just subtract our exponents. Yeah, 5 minus 2 is 3, right? Yes. And then 1 minus 7 is -6. Negative means I'm dividing by it. Very good. So here's part of my answer. And look how much condensed this looks compared to all that. So why would it be on the top? Because look, where are all my y's? Right? Why would it be on top? Because 5 minus 2 is 3. And is 3 meaning numerator or 3 meaning denominator divide? You guys would say, oh, Miss Johnson, I understand now. Yes, yes, yes. Very good. So now I'm just going to go through and cube root everybody, literally cube root everybody. Cube root of 16, cube root of y cubed, cube root of x to the 6th. So with that, right, everybody gets cube root. Imagine this part right here. This is this step right here where everybody gets to the 1/2. So 16 to the 1/3, y cubed to the 1/3, x to the 6th to the 1/3. Everybody see that? Okay, so 16 to the 1/3. I'm going to break 16 down over here. What times what gives me 16? What times what gives me 16? Yeah, so someone says 4 times 4, someone else says 8 times 2. I generally do 4 times 4. So this is 2 times 2 times 2 times 2. I'm now looking for sets of what though? I'm no longer looking for pairs of shoes. How many in a set? Yes. Where did that person, why 3? Where'd you get 3 from? Where'd you get 3 from? Oh, because the cube root. Exactly. So don't turn your brain off on this part and just start looking for pairs and say, oh, Ms. Johnson, I know what the cube root of 16 is. It's 2 times 2, it's 4. No, the cube root is now looking for sets of 3. So I don't know what comes in a set of 3. I don't know. I'm always looking for sets of 3 because I have 3 children. Oops. So I'm going to circle this set of 3 right here. And this guy gets to go on the outside. He gets to go on the outside because I have a complete set. Thank you. Okay. Where does, what happens to this guy? What happens to this 2? Yeah, you leave them alone. Mistakes that people make is that they forget to put a little cube root right here, this little cube root, and they'll write 2 square root of 2. And that's wrong. If it starts as a cube root, it'll finish as a cube root. So there goes my 16. The 16 goes 2 cube root of 2. Hey, what's the cube root of y cubed? What's the cube root of y cubed? Yeah, it's just y. And notice I don't even have to, for some of you, I don't even have to draw it all out. You guys can kind of see that. What about this one? What's the cube root of x to the 6th? Yeah, it cancels out. Someone noticed that too. Very good. These two undo each other. Very good. I like that language as well. Yeah, what's the cube root of x to the 6th? What would that be? Very good. Someone said x squared. Exactly. Ms. Johnson, x squared. Yeah, because imagine if I wrote it all out, right? It would be x, 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 x. I'd have 2 sets of x's. So x times x is x squared. So I'm going to make my final answer here. My final answer is going to be 2y cube root of 2 over x squared. Ms. Johnson, why did you pull that y in the front? So in general, I put all the people outside in front because I want to make it clear to you that they're outside and not inside. Sometimes back in the day when you guys were all, had to write this out by hand, some students would write it like this and they'd go 4x, y. Right. And they'd say, oh, Ms. Johnson, this is my answer. And I was confused. I'm like, is y inside? is y outside. So to make it very clear, I always put people on the outside in front. So it's very clear. Yeah, very good. Okay, so for the rest of this activity, it's just more of you practicing. Some of them are with exponents that are negative. I really want you to take your time with each of these to see if you can do them on your own. Okay, so very good job, very hard work that you all put in today. I appreciate it greatly.